In elementary calculus, we learn the rules of differentiation. In this video, I'm going to explain 4 rules of differentiation: the product rule, the quotient rule, the chain rule, and the sum and difference rule. I'm going to start with the sum and difference rule because it is a straightforward rule. Then I go to the other rules. All you need to know here is, if you're given a question, which rule applies. Because if you don't use the right rule, you will struggle to get your answers right. So make sure you understand the rules correctly. In most cases, you are given the rules as formulae in your on your formula sheet. So you need to know which formula really is representing the product rule, which one is representing the quotient rule, which one is representing the chain rule. It's all about experience and practice. So let's start. If you have a function or an equation like y is equals to 3x to the power 5, we can find dy dx, which is the derivative or the first derivative of y is equals to 3x to the power 5. So let's find dy dx. What we mean here is the derivative of y with respect to x. X is our variable in this case. So in this case, what we do is we take the 3, we multiply it by 5, which is the power. And on our x, we're going to reduce the power by 1, which means we have 5 minus 1, which gives us 15x to the power of 4. So this is the first derivative of y is equals to 3x to the power 5. Done. If you have a function like a trigonometric function like sine x, so if I have y is equals to sine x, dy dx is equals to cos x. I can also have a function like y is equals to e to the power of x. From here, dy dx is equals to e to the power of x. So this one and this one, these are what we call standard derivatives. You are usually given them on your formula sheet. They list them, the function and the derivative and maybe the integral. It can be listed on your formula sheet. So you don't have to struggle much. You just go to your formula sheet and check what is there. Now, I'm going to use this to illustrate the sum and difference rule. Now, I have a function, I have an equation incorporating all of these, all of them, 3 together. So this is how you apply the sum and difference rule. Let me clear my board. I have y is equals to 3x to the power 5 plus sine x minus e to the power of x plus, let's say, 7. So we have a sum here of terms. So we have 4 terms. So term number 1, term number 2, term number 3, term number 4, all separated by a plus or a minus, which means it's either a sum or a difference. The applicable rule in this case is the sum and difference rule. So I'm just going to illustrate with this example. So we have dy dx equals to, we just have to know how to differentiate each of the terms. That is what we do. So the derivative here is the derivative of each of the terms, added or subtracted. Now, the first one is going to give us 15 x to the power 4. We did it, and we know that if we differentiate sine x, the answer is cos x. So we plus here the cosine of x minus e to the power x. If we differentiate e to the power x, we get e to the power x plus a 0, because 7 is a constant. If you differentiate a constant, we get a 0. So this is what you do when you're using the sum and difference rule. For the purposes of a test or an exam, if you don't know one of the terms, if you don't know how to differentiate one of the terms, don't stop. Differentiate those that you know, because when we are marking, we'll mark each term. If this one is correct, we mark it. If this one is correct, we mark it. If the third one is wrong, we cancel it. See? So in this case, we're going to mark all of them because they are correct. We may not write the 0. We may not write the 0, which means our answer will be 15 x to the power 4. That's cos x minus e to the power of x. That's it. It doesn't matter how many terms or how the terms look like, whether it's a trigonometric function, or it's simple algebra, or it's an exponential function, or it's a constant. It really doesn't matter, as long you know how to differentiate each of the terms of this equation. You can use the difference and the sum rule to do it. All right, let's move on to the next rule. I'm going now to go to the product rule. When we say a product, it is the answer that we get after multiplying two or more things. So a product, we get it after multiplication. So we use the product rule if we have functions multiplying each other. In this case, I have, let's say I have here y is equals to x cubed sine x. This is a product. I am multiplying here this function by that function. So we have two functions here. Let me give them names. Let us say the first one is f of x. The second one is a g of x. Now from here we have a general formula for the product rule that says dy dx is equals to f of x times g prime of x plus, you can also use it for yes, plus f prime of x times g of x. In other words, you start by differentiating one of the terms and multiplying it by the other term. You multiply the derivative by the other term, then you go on to differentiate the other term and multiply it by the other term. So in our case, let us go straight to the answer. So dy dx is equals to, I'm going to write x cubed as it was, and then I differentiate sine x, I get a cos, so cosine x, plus I differentiate x cubed, which gives me 3x squared times sine x. This is the product rule. You apply the product rule once you see two functions multiplying each other. Then apply the product rule there. It works. That's all you have to do. I hope it's very clear. You can do more examples. Go around and find more examples of where you can use the product rule. Whenever you see two functions multiplying each other, you can apply the product rule. Let me go to the other rule, the chain rule. The chain rule. We use the chain rule if we're differentiating a function of a function. We use it when we are differentiating a function of a function. So it's for a function of a function. I'm going to give examples of what we call functions of functions. If I have, let us say I have y is equals to cos x squared. Okay, I'll say, let's say cos 3x. Let me put brackets here. The function here is a cosine function. This is a trig function. However, there is another function also. 3x is a function here. So the cosine function is there. It has another function involved. This is what we mean by a function of a function. So this is one example. Another example of a function is, let's say we have y is equals to x squared plus 2 plus 2x, all of this to the power of let's say 5. This is also a function of a function, so we use it in these cases. Or let me say I have an exponential function. Y is equals to, let's say, e to the power of 7x. Again, this is a function of a function, and in all these three cases we use the chain rule. So what does the chain rule say? I'm going to write a formula representing the chain rule. The chain rule says if you have y is equals to f of x right, we have y. I'm just going to give an example here of y equals to u to the power of, let's say, n, where u itself, where u is a function of x. Because this is a function of a function. This is an example of a function of a function. Or the other one that I had was y equals to e to the power of u, where u itself is a function of x. Or the other one that I had, like y is equal to sine u, where this u is a function of x. If we have situations like that, the chain rule says dy dx is equals to dy du times du dx. Y is equals to dy du times du dx. This is the chain rule formula. So if you go on your formula sheet and you see a formula like this one, that it is representing the chain rule. So this is the chain rule. So let us apply it to a situation of, here we have y is equals to sine 5x. This is a function of a function. So dy dx is equals to dy du, which means you are just differentiating this the way it is. You differentiate it as a sine, as a function of sine. So if we differentiate sine, we get a cosine. So it is cos 5x. We multiply that by the derivative of u, which is the derivative of 5x, which is 5. Let us rewrite our answer. So this is like 5 cos 5x. We have applied the chain rule here. If you want to do it systematically, let us do the same question. Systematically, we have y equals to sine 5 of x, 5x. We said our u is sine no, our u is 5x, obviously. So our u is 5x. From here, it means du dx is 5. Then our y, obviously, it will be equal to sine u dy du will be equals to cos u. Now we have the two components of our chain rule, dy du and du dx. To get our dy dx, therefore, we know that it is dy du, which is cos u, times du dx, which is 5. We just rearrange. Whenever we're doing such kind of questions, try to write the constant before you write it before you write your trig function. So this is like 5 cos u, but we know our u is 5x, so we can replace it there. So this is 5 cos 5x. I'm using here the chain rule. Systematically. Let me do another example. The chain rule, we have y is equals to, in brackets, 5x squared plus 2, all this to the power of 10. Someone who is a novice can think of expanding this bracket, but guys, if you have to the power of 10, the expansion will be so long. If you try to expand and then differentiate each term, you're going to take a long time, because this question might be just, maybe I will just give you 3 marks for this question. It's a 3-mark question, even 2 marks, because it is a straightforward question. This is where you apply the chain rule. In short, or in summary, your answer will just be dy dx is equals to 10. I'm multiplying by the power 5x squared plus 2. I reduce this power by 1 to the power 9. Then I multiply by the derivative of what is in our bracket, which is 10x. Then I just rearrange 10 times 10x, that will be 100x, 5x squared plus 2 to the power of 9. That's it. This is what you do when you're given a question like this. I want now to write it systematically to show you what I'm doing here, but in summary, which is something that you should learn to do so that you can do your derivatives fast. Multiply by the power, reduce the power by 1, and multiply by the derivative of what is inside your bracket. You're done. This is the application of the chain rule. I'm applying the chain rule here. And so let me do it systematically. I'm going to write the question again. So y is equals to 5x squared plus 2 all to the power of 10. From here, I can rewrite this as y is equals to u to the power of 10. I'm doing the u substitution here. I know my u, so it's y equals to u to the power of 10, which means dy du is 10 u to the power of 9. Then I also have to find du dx. Remember, u is a function of x. We know our u. From here, we can also say our u. it is 5x squared plus 2. This part here, which is in the bracket, that is our u. From here we can find du dx. So du dx, if we differentiate 5x squared, we get 10x. If we differentiate 2, we get a 0 because it is a constant. So du dx is just 10x. From here, we can now write our answer. We know our answer is dy dx is dy du times du dx. So our dy du, we have it here, is 10 u to the power 9 times 10x. This is our answer, but we know we can multiply this one and that one together, and we also know that our u is 5x squared plus 2, so we can write our final answer as dy dx equals to 100x. Where there was u, we're going to put 5x squared plus 2 to the power of 9. Okay, this is the final answer. This is what we do when we are using the chain rule. I'm going to use the chain rule again on differentiating a function like y is equals to ln, the natural logarithm of 7x plus 8. This is also a function of a function. We know how to differentiate ln x. If I have something like y equals to ln x, the derivative of ln x is just 1 over x. So dy dx is 1 over x. So every time you're differentiating a ln function, it's 1 over something times something. So let us apply the chain rule here. You can apply the chain rule. I'm going to apply the chain rule in this case. I'm going to do it fast. So dy dx will be equals to, you take 1 over the function here, which is 7x plus 8. Then you multiply it by the derivative of what is in our bracket, which is just 7. Then rearrange. This means 7 over 7x plus 8. This should be your final answer in this case. It is an application of the chain rule again. Now I'm going to illustrate how the chain rule is coming into effect here. It is y equals to ln 7x plus 8. It means our y is equal to ln u, which gives us dy du is 1 over u. That is correct. Then we know our u is 7x plus 8. So u is 7x plus 8. From here we can get du dx is 7, because we're simply differentiating this function here with respect to x. We get a 7. Now from here we can now finish up our question. We know that dy dx is dy du times du dx. So this is 1 over u times 7. We got this, but we know our u. Now we know our u, so this is like 7 over our u, which was 7x plus 8. I hope it's clear to everyone. The kind of functions where you use the chain rule. I'm going to, my last one would be exponential function. y is equals to e to the power, let us say 3x. This is like having y equals to e to the power of u, where u is 3x. So from here we can write dy du. If we differentiate e to the power u, we get e to the power u. We have this on our formula sheet, so we don't have to worry about that. We can also get here, we know that our u is equals to 3x, from which we can conclude that du dx is 3. Now, our dy dx, we know that our dy dx is dy du times du dx. Dy du is e to the power of u times du dx, which is a 3. But we know that this u here is actually 3x. So we can now substitute and we get our answer as 3 e to the power of 3x. This is our final answer, and this kind of question is an application of the chain rule once again. You may be lucky that all these things that I'm mentioning are actually given on your formula sheets. You have some formula sheets written in this form where they say if y is equals to the ln of f of x, then dy dx is equals to f prime of x over f of x. You're going to see questions like formula sheets written like this. So if you're so lucky to see formula sheets written like this, then you have it. It's quite straightforward. In the same formula sheet, you can find something written like y equals to sine f of x, which is essentially a function of a function, and they say dy dx will be equal to f prime of x cos f of x. You may find formula sheets written like this. If you do, then it is quite easy to apply the chain rule, because this formula here is already showing that you have applied the chain rule. This is the application of the chain rule. Anyway, let me move to the other rule, which is the quotient rule. So this is the last rule, the quotient rule. Quotient rule. In mathematics, what we call a quotient, it is the answer that we get after dividing two things. So if we divide a 10 by 5, the quotient is 2. So we have a quotient if we have a fraction. That is a quotient. We apply the quotient rule for functions like y equals to f of x over g of x. So you have two functions here. The other one is the numerator, the other one is the denominator. They are different functions. If you have that, you can apply the quotient rule, because what we have here is a quotient. That is a quotient. So I'm going to just put the formula for the quotient rule. That formula will usually be given in your formula sheet. If you're not given in your formula sheet, you need to memorize it. Because the quotient rule involves a minus sign, it is very important that when you are using the formula, you use it correctly, because if you just misplace one of the terms there, you're going to have a wrong answer. Let me illustrate what I mean here, because the formula for the quotient rule says dy dx is equals to the g of x, which means the denominator, you're going to write it as it was, or as it is, g of x. You multiply this by the derivative of the numerator, then you subtract f of x as it was, multiplied by g prime of x, all over g of x all of this, you square it. This is the formula for the quotient rule. If you have a quotient, you apply this formula here. And because of this negative sign here, guys, once you see this negative sign, you have to be careful because you can't start with this part. You have to start with this part. So know which one to start with, know what to differentiate first, and know what to differentiate later. It is very important that you do that. Let us illustrate this with an example. Let us say I have y equals to let me say sine x over x squared. So I have here a quotient because the numerator is sine x and the denominator is x squared. This is a quotient. Now I can apply the quotient rule because of this. So dy dx is equals to, then this is the I put a fraction because it should be a fraction. The first task is to square our denominator, so this x squared is going to be squared. Then in the numerator we start with the denominator, we write x squared. We are not going to differentiate it now. We multiply it by the derivative of our numerator, which is cos x. We subtract. Now we differentiate now the denominator, which means we get 2x. We multiply it by sine x. Then from here, whatever you do, you're just simplifying. So we have x squared minus, we have x squared cos x. So x squared cos x minus 2x sine x all over x to the power 4. We can simplify this because if you look at our numerator, we have something common there. We can take out x and we cancel out with the x in the denominator. So let us rewrite this so that I can simplify for you. We usually expect you to simplify your answers. You can leave it like this and nothing wrong there, but we expect you to simplify the answers. So we said we have our dy x as x squared cosine of x minus 2x sine of x, all of this over x to the power 4. I said we can factor out x from the numerator, so we have x, then x cos x minus 2 sine of x all over x to the power 4. Algebra allows us to cancel here and here so that we have x cubed here in the end. So our final answer will be x cosine of x minus 2 sine of x over x cubed. This is our answer. You can write it in different forms. It really doesn't matter, but this is our answer. I want to write this in a different form. Allow me to write this in a different form. You know, if you have a fraction like this, it means x cos x over x cubed minus 2 sine x over x cubed again. So let us write it in that format and you see what is going to happen. So it will be dy dx is equals to x cos x over x cubed minus a 2 sine of x over x cubed. From here, we are allowed to cancel here again, such that our final answer will just be cos x over x squared minus 2 sine x over x cubed. Take note of this answer because I want to show you something that you can do again. Because there are people who get confused by the quotient rule. There are times when you can manipulate your question to look like a product and you apply the product rule. If the product rule is quite easy for you, you can do that. I'm going to apply it to this question. We had y equals to sine x over x squared. I can write this as y equals to x minus 2 sine x, x to the power minus 2 sine x. I can do this because I'm simply applying the laws of exponents. Now, if it is like this, it now looks like a product. See? It now looks like a product, and I'm going to apply the product rule to this function. So let's go. So dy dx, using the product rule, I keep my first term, and so this is x to the power minus 2. I multiply it by the derivative of sine x, which is cos x, plus, now I'm going to differentiate a x to the power minus 2. If I differentiate that, I get minus 2 x to the power minus 2, not x to the power minus 3. Then I multiply this by sine x. I have applied the product rule to this case. Now let me simplify so that I don't have negative powers. If I do that, this one becomes 1 over x squared, so that in the end I have cosine of x over x squared, plus minus, it becomes a minus, 2 is here, sine x, x to the power minus 3 goes to the denominator as x cubed. If you look at this answer, it is the same as the answer that I got from using the quotient rule. It is the same, but I manipulated my question so that it looks like a quotient, so that it looks like a product. Then I applied the product rule. I think I have done all the laws or all the rules of differentiation. The 4 rules that I wanted to do in this video, I have covered them. You should practice. If you have any question or any comment, just write in the comment section below. Otherwise, thank you for watching. Keep watching the videos, or if you want to request a video for a certain subject or a certain topic, just let me know and I'll do a video for that. Subscribe to the channel and give a thumbs up to the video. Thank you.